Hey, my name is Felipe and welcome to my channel. In today's tutorial, I'm going to show you how to use the Raspberry Pi AI kit with your own custom object detector. In one of my previous videos, I already showed you a very comprehensive tutorial on how to use the Raspberry Pi AI kit. I show you how to set it up and running, and I also show you how to make inferences with different type of cameras. But in that previous video, we were using some pre-trained model weights. We were using some model weights from the Hailo Model Zoo. But the thing is, if you're using one of these devices, a Hailo accelerator with a Raspberry Pi, then most likely you don't want to use some pre-trained model weights. You want to use it with your own custom object detector. So in this video, I'm going to show you how to do it. I'm going to show you the entire process from taking your model weights in its original pytorch format and converting those model weights into another format which you can use in the Hailo accelerator. This is going to be a very interesting, a very awesome tutorial, but something that's very important is that in today's tutorial, I am not going to show you how to train a custom object detector. If you want to know how to train your own custom object detector, then I invite you to watch another of my previous videos where I show you the entire process. Oh my god, in this previous video, I show you everything that has to do with training your own custom object detector, from all the different sources of data you can use to train your model, also how to annotate the data, how to evaluate the model you train, how to make inferences. This previous video is perhaps one of the most comprehensive tutorials on how to train your own custom object detectors, so I definitely invite you to check it out. Now let me show you the model I am going to use in this process. I am going to use an object detector I trained to detect alpacas, an object detector I trained with this dataset you can see over here, and I trained this model using YOLO V8. These are the model weights I have produced. Alpaca detector YOLO V8 nano.pt. So these are the model weights which I'm going to convert into another format which I will be able to execute in the Hailo accelerator. Now let me show you some resources we are going to use in this tutorial. For today's project, you will need to create an account in the Hailo AI developer zone. So you need to go here, hailo.ai/developer zone, and you need to create an account. Please make sure to do it, because otherwise you will not be able to download some files which you will need later on in this tutorial. And we're also going to be using an EC2 instance in AWS, because this is a process we need to do from an Ubuntu based computer, and in order to make it a bit easier to follow along, in order to make it a bit easier for you to just execute all the steps I show you in this process, I decided to just use an EC2 instance in AWS. This is going to make the entire process much easier to follow along. Now, these are the resources we will be using in this tutorial, and before we get started, let me tell you something. Let me address the elephant in the room, right? This thing I have over here. So basically, I broke my arm. I broke my arm. That's basically what's going on over here. 3 weeks ago, I had an accident, and as a result, I have to use this thing you can see over here. So now I'm doing much better, and I want to thank all of you who have supported me, and I want to tell you guys that I'm doing much better, and I am almost fully recovered. So thanks all of you. So yeah, that's basically the elephant in the room, right? The why I'm using all of this thing over here. Now let's continue with the tutorial. Okay, now let me show you the files you will need to download from the Hailo AI developer zone. You will need to go here to software downloads, and you will need to download 2 files. Let me show you. Please remember to select this option over here, Hailo 8.8L, and then you will need to download the Dataflow compiler, which is this one over here. You will have only one option, so it's going to be impossible to make a mistake. And then I'm sure I already downloaded this file. I'm going to download this file again. And then you will also need to download the model zoo, which is this other file over here. And in my case, I already downloaded the file. I'm going to download the file again, it doesn't matter, and that's pretty much all. So please remember to download these 2 files, otherwise you will not be able to work in this process. Now let me show you. Now we will need to launch an EC2 instance in AWS, and we will need to take these files into the EC2 instance. There are many ways in which we can do it, but I'm going to show you a way which I think is going to be perhaps one of the simplest way to do it, which is basically just creating a directory in Google Drive and just uploading all the files into your Google Drive. Then we will download all these files from the EC2 instance. I think this is going to be perhaps the most straightforward way to do it. So you can see I have already uploaded the Dataflow compiler and the model zoo, and I have this other file over here which is data.zip. Data.zip is basically the images I show you over here and also the model weights in PyTorch format, right? I have compressed this directory and I have created this file over here which is data.zip. So it's basically the images and the model weights in PyTorch format. That's going to be pretty much all. I think this is going to be the easiest way to download the files from the EC2 instance. Now we will launch. I'm going to click here on launch instances. I'm going to name this instance something like convert to Hailo. Okay, I'm going to select Ubuntu, and then I am going to make sure to select Ubuntu Server 22.04. Okay, then the instance type, this is very important because we need to select an instance type with at least 16 gigabytes of RAM memory. So I'm going to select a T2X large instance type. I click here, and that's going to be pretty much all. Remember that absolutely everything you do in AWS is not free, but you will need to pay for it. And in the case of this EC2 instance, it costs around 37 cents per hour, right? So this is something you need to keep in mind. Then I will need to select my key pair, and that's pretty much all. The only thing I'm going to change here is the storage size. I'm going to set it in 40 gigabytes. It's much more space than what we need for this process. We are not going to use 40 gigas, but just in case, I'm going to click launch instance. And now we need to wait a few seconds. Okay, once the instance is launched, we are going to SSH into the EC2 instance. I'm going to copy this value over here, and then I'm going to open a terminal. And I'm just going to SSH like this. Right, SSH -i, my key pair, and then Ubuntu at the public DNS. Yes, and that's pretty much all. Okay, so the first thing we will be doing is installing virtual env, right? Because we will be creating a virtual environment. So I'm going to type virtual env, and this is going to remind me that virtual env is not installed and that I need to install virtual env by running this command. The thing is, we need to run an apt-get update first. I almost forget. Okay, so remember I'm using only one hand, so everything is going to be a bit slower in this tutorial. So yeah, please bear with me. I am still getting used to typing with only one hand, and it's very slow. So now we should be able to install virtual env. And we will create a virtual environment with Python 3.10. Okay, let's verify that Python 3 is Python 3.10, right? The default Python 3 version is Python 3.10, so everything is perfect. Now I'm just going to create a new virtual environment, virtual env, something like this. Okay, now I'm going to activate the virtual environment. Okay, and now I am going to download the files I have over here. And in order to do so, the first thing I'm going to do is to make it public, so it's going to be easier to download from the EC2 instance. So I'm going to do something like this. Okay, now all of them are public. I'm just going to copy link of the Dataflow compiler, and I'm going to do something like this. The first thing I'm going to do is to install gdown, which is the Python library we are going to use in order to download all the files here in Google Drive. Then I am going to type gdown and the file ID, which is this one over here. Okay, then I am going to download the model soup. So gdown, and then I'm going to download the data. Oh, it's in progress. Okay. Okay. Okay, now let's clear the terminal and let's do it one step at a time. The first thing I'm going to do is to install the Dataflow compiler. So this is Hailo Dataflow compiler. Okay, we have an error because there's something missing, which is this package over here. In order to install that package, we need to run this command over here. So we are going to install Graphics and also Graphics Dev. I'm just going to install these two packages and I'm going to wait a few minutes. Okay, and now I'm going to try to install the Dataflow compiler again. Okay, let me clear the terminal and now let's pp install the model zoo. Hailo model zoo. Okay, now the next step in this process is uncompressing this file over here, data.zip. So let me show you. In order to do so, I will need to install unzip first, which is something like this. And now unzip data.zip here. Okay, now this data, you can see we have the images and we also have the file in pytorch format. Okay, now let's continue with this process. The next step will be taking our model weights and to convert them into the onnx format. Eventually, we will convert them into the Hailo format, but for now, we need to do this conversion, right? We need to convert it into onnx. Let me show you. In order to do so, I am going to use the Ultralytics package. And I'm going to install this package like this, pip install Ultralytics. Remember that YOLO v8 is a YOLO version released by Ultralytics. So the simplest way to convert these model weights to onnx will be using the Ultralytics package. And now in order to convert the model weights to onnx, I will type this command over here. You can find this command here in the Ultralytics documentation. Basically, it's a very simple instruction. We need to specify the model weights, which in my case is here. The file name is alpaca detector YOLO v8 nano.pt. And that's pretty much all. I remember I had this error before, but I don't remember how I solved the error. Oh yes, I remember. Basically, you need to run an update and then installing these packages over here, and that's pretty much all. Okay, now let's try to execute this command again. We are running YOLO export the model weights and then format onnx. Okay, everything seems to be just fine. Now I'm going to do ls data, and you can see this is the model we have converted. Now we can continue with this process. And now the only thing we need to do, let me clear the terminal first, is to execute the model zoo like this, Hailo model zoo, compile. I'm going to execute the help first. And these are all the different flags and everything we can use with this model. So basically I'm going to execute Hailo model zoo. I'm going to specify the location of our checkpoint, which is data alpaca detector. The file we just created, onnx. Then we need to specify the architecture. Remember, we could be using YOLO 8, we could be using Hailo 8 or Hailo 8L, right? So we need to specify that in our case is 8L. Then the number of classes, this flag over here, my object detector is able to detect only one class, which is alpaca, so I'm going to set the number of classes in 1. We also need to input the this other argument, which is caliph path. These are the images which will be used in order to calibrate the model we will be converting. And what I usually used as calibration data is the training data, right? I used some of the images I used to train the object detector, and those are the images I used as calibration data. That's my criteria. So that's what I'm going to do now. This is going to be data, and then alpaca detector, which was something like images train. Okay, that's the directory of the training data. Then let's continue. That's pretty much all. Something else which is very important is this argument over here, because we can convert pretty much any architecture we want into the Hailo format. I'm not sure if any architecture we want, but we have a lot of options, right? We can just choose between a lot of options. Let me show you. If I go here to the Hailo model zoo GitHub repository, and I go to config and then networks, you can see we have a lot of different options in order to convert into the Hailo format. Efficient net, we also have, let me show you, MobileNet, ResNet, then SSD MobileNet, YOLO 11, YOLO v10, YOLO v3, YOLO v4, YOLO v5, YOLO v7, YOLO v6, right? We have a lot of options, so we need to tell Hailo we will be converting a model from YOLO v8 nano, right? We will need to input this value over here, this YAML file over here. And I will be using this file over here. If I'm not mistaken, this is going to be bemp live site packages, then Hailo model zoo, and then config networks, and then YOLO v8 nano dot YAML. Okay. Let's try again. Hailo also, I forgot to add the compile argument. Okay. Checkpoint, hardware architecture, classes 1, caliph path, and then no, YAML goes here. Okay, let's see now. Because this file over here is the same file I'm showing you over here in the GitHub repository. Okay, let's see what happens. We are not meeting one of the requirements, which is this one over here. So I am going to sudo apt get install python 3 tk. Okay, let's try now. Let's see what happens. Oh, I forgot the V8. It's a B here. Okay. Okay, now everything seems to be working just fine. Something else is not working. It seems we are looking for this file inside this directory. And for some reason, we do not have this file and this directory in the virtual environment. This is a bit weird. I'm not sure why we have this error, because if I look in the GitHub repository, if I go here, we are generic, then we move one step back, and then we move another step, right? So we are here, config. If I go to config, I do have this directory, post-process config, which is this one over here. So I'm not sure why this directory is not in the virtual environment. I'm not sure why, but the easiest way to fix this issue, perhaps, I'm not sure how clean this is, but this is the way I found to fix this issue, is basically cloning the entire repository. This repository. And then I'm just going to copy this directory, post-process config, into the directory Hailo model so it's looking for, right, into this directory over here. So I'm just going to take this directory, and I'm going to copy this directory into this directory over here. Okay, So this is going to work just fine. I have already prepared this tutorial and I know that now we will not have any problem whatsoever. But if you want me to be honest, I don't like this solution at all, because it doesn't really seem very clean, right? It seems like this is not the right way to do it, but I don't know. Yeah, it works. It works very well. So now let's try to do it again and you will see that now we will not have any problem whatsoever. Okay, and that's pretty much all. You can see that the process has been executed correctly, no problem whatsoever, and the model weights have been created here in YOLO B8N.HEF, right? Those are the model weights we have created, and that's the file we are going to use in order to execute in the Hailo accelerator. So everything is ready and we are almost there. The only thing we need to do now is to take these model weights and to copy the file into our local computer, right? So this is how I'm going to do it. I'm going to open a terminal and I'm going to execute something like this. So scp-i, the location of my key pair, and then the file we are going to copy, and then I'm going to name the file in my local computer something like alpaca detector.hef. Okay, that's pretty much all. And now the only thing we need to do is to take this file and to copy this file into our Raspberry Pi. But something we could do first is to get back here to the EC2 instance and to shut it down, right? Because we're not going to use it anymore. And remember that you are going to be paying by the hour, right? So if we're not going to use it anymore, it doesn't make any sense whatsoever to keep the instance running. So let's go back here to the terminal. I'm going to clear the terminal and now let's SSH into the Raspberry Pi. I am going to, perhaps I can search history. Remember, only one hand, so please be patient. Something like this. So I am going to SSH first and then we are going to copy the file. But let's do it one step at a time. I'm going to, I think I need to connect my Raspberry Pi. So one moment, please. Okay, the Raspberry Pi is now connected. Everything should be ready. And let's see now. I'm going to input my password, which is something like this. Okay, and then let's cd into this directory. Remember, I am just going to execute the same file we executed in one of my previous videos where I show you how to work with the Raspberry Pi AI kit, right? I'm going to do exactly the same process. So I'm going to activate the virtual environment, something like this. Okay, then I am going to, perhaps we can try to execute the pipeline with the pre-trained models just to make sure everything is working properly, and then we can run the pipeline with our new model weights, right? So the first thing we need to do, we also need to execute this instruction over here, and then we need to make sure we are using the right camera, so it's 0. Okay, I'm going to copy and paste this, something like this, paste. Okay, video 0, so everything should work just fine. If I press enter, we should run the pipeline with the pre-trained models. Everything is okay. So I am going to run the pipeline using the USB camera, which is right here in front of me, and we can see that everything is working just fine using the pre-trained model weights. In order to be 100% sure, I am going to connect using a VNC viewer the same way we did in one of my previous videos. I definitely invite you to check that video out, because in that previous video we already did the entire process I am doing now, right? Running the Hailo pipeline on a USB camera. So that's why I'm not explaining everything we are doing now. I'm going to run it again, and now we should see so everything is working fine. You can see it's detecting me as a person, then the clock, then couch, everything is working just fine. A bottle over here. So we are using the pre-trained model weights, and everything seems to be working perfectly. Now let's get back here and let's terminate it. So now pretty much the only thing we need to do is to copy the model weights into the Raspberry Pi. So I am going to type something like this. We are going to copy the model weights, which are located here, into the Raspberry Pi. Obviously, I have already prepared this tutorial, so actually the model weights are already here in the Raspberry Pi, but this is only to show you how to do it, right? So this is pretty much all, and now if I press ls, you are going to see actually ls here, right? You can see here alpaca detector.hef. So everything seems to be working just fine. Now let's execute the pipeline again, but this time let's execute it with our model weights, right? So let's do something like this. In order to be sure, I am going to do something like this, and pretty much the only thing we need to do is to use this argument over here, and the location of the model weights. Okay, this should be pretty much all. Let's see what happens. So we are running the pipeline, everything seems to be working well, and if I get back here, you can see we're not detecting anything. We are detecting something. You can see it says person. Every time we detect something, it says person. Do not mind the class names, because this is hard-coded. This is hard-coded at some point in the code, so it's taking the class names from the Coco categories, right? So the first category is person, and that's why it says it's person. So do not mind the class name, but this is basically the category is detecting. So now it's not detecting any alpaca, because there's not any alpaca whatsoever, right? It's only me, and it's detecting me as an alpaca, I guess. But let's see what happens if we put an alpaca in front of the camera, right? Let's see if we can do that. So I think one of the best ways to do it is just using one of these pictures of alpacas over here, right? Perhaps we can use this one over here. I think this one really looks like a very proper alpaca. Let's see what happens. So I'm just going to use it like this. This is not going to be easy because I have only one hand, right? Okay, and you can see that it's detecting the alpaca in the picture with a very high confidence, so everything seems to be working just fine. It's detecting me sometimes as an alpaca too, with a very low confidence, but it's detecting me as an alpaca anyway. Yeah, it seems I do look like an alpaca. I think I do look like an alpaca a bit, right? Yeah, I don't know. But anyway, you can see that it's detecting the alpaca in the picture with a very high confidence, so everything seems to be working just fine. And this is working very well, even though we have a huge glare in the picture, because I have a few lights like in front of the computer. So I have a huge glare, and nevertheless we are detecting the alpaca with a very high confidence. So yeah, everything seems to be working just fine. So that's going to be all for this video. Let me know what you think in the comments below, and let me know what other videos or topics you would like to see next on this channel. Let me know in the comments below. See you on my next video.